We're going to do a little bit of a whirlwind tour in renewables, the other renewables, and first up is wind power. This is the cumulative installed wind power capacity in leading countries going from 1980 to 2013. So China is leading in terms of megawatts produced. This is a different look at the top wind power in countries per capita for 2012. So Denmark is leading. They use a lot of wind power, and then Spain, Portugal, Sweden are up there, Germany, Ireland, and then US and Canada. Winds are the result of unequal heating of the surface of the earth by the sun. So warmer air rises, cooler, denser air sinks, and that creates circulation patterns when combined with the rotation of the earth. And then we can harness that energy generated from the kinetic energy of the moving air using these wind turbines. These are turbine generators, so the wind approaches the turbine here, rotates those blades and a rotor, and then that rotor and blades rotate this shaft here, and then that shaft is going to spin either a magnet in an electrical coil or the coil around the magnet, and then that coil and magnet result in an electrical output. This is the fastest growing major source of electricity in the world. There's a pretty large generating capacity, but the US is only obtaining less than 6% of our electricity from wind, and the largest amounts in the US are coming from California and Texas. These wind turbines are as tall as 100 meters, and the blades are 40 to 75 meters long. To give you an idea of what good wind conditions are for a wind turbine, in average wind conditions, a wind turbine on land might produce electricity 25% of the time. So good wind resources have an average annual wind speed of at least 13 miles per hour. 13 miles per hour is about 6 meters per second, so that's a cutoff of about here on this wind speed scale. So a lot of this area in the Midwest is really good for wind turbines. While the wind turbines are spinning, they can produce 2,000 to 3,000 kilowatts. That's 4.4 million kilowatt hours a year, which can supply 400 homes. So one wind turbine can supply 400 homes with electricity. And wind farms are often on land in places where the wind is blowing up to 25% of the time. Extreme winds can be challenging for wind turbines, and therefore at super high speeds, like 25 meters per second, the turbine will actually turn off. And then there is a cut-in speed, right? So that's about 3.5 meters per second. So you need winds of at least 3.5 meters per second for the turbine to even turn on. And then as you can see, powers when the wind gets faster and faster, up to a point, which is about 13 meters per second, where the power output is going to remain the same regardless of how much faster the wind is blowing. And then at 25, you're going to get a shut off of the turbine to avoid damage. Offshore wind is really desirable for electricity generation because offshore winds tend to blow harder and more uniformly than on land. And also 53% of our nation's population lives in coastal areas. So therefore you're getting the power generated closer to where people are living, so you don't have to transmit it as far. This is a map from that same article that I referenced with solar power, visualizing the surface area required to power the world with zero carbon emissions and only offshore wind. So those yellow areas on the coast are the areas that you would need to have wind farms. All right, so again, we're going to do wind power, advantages, and disadvantages. Some of our advantages, similar to most renewables, is you have no pollution, no greenhouse gases. Once they're installed, the only fossil fuel is the workers that have to travel to maintain them. Another advantage is you can share the land with other uses. like grazing cattle. Some of the disadvantages of wind energy, one is again the battery problem. If you need to store the electricity off of the grid, again, batteries are getting better. Another disadvantage are birds and bats that can get killed by collisions. Now, although any death of living creatures is certainly not what you want, there's a much higher number of birds that are killed by cats, especially feral cats, and then collisions with building glass. Some final disadvantages are you can get some habitat fragmentation. This is actually the ridge windmills that you can see from Plymouth. Also aesthetics, some people really don't like the look of wind turbines. And then you still have to have those electrical transmission lines. And also some people don't like the noise that they make. Next up is hydropower, and there's actually two types of methods of getting hydropower. The first are these run-of-the-river systems. In these systems, water is retained behind this low dam here for the small river. It runs through a channel, down a grade, and then it returns to the river down this grade through this turbine and generator right here. These don't store water in a reservoir. There's relatively little flooding upstream. The seasonal changes in the flow of the river are not disrupted. These systems are generally small. They rely on natural water flow and therefore have intermittent electricity generation because heavy flow can't be stored, so no electricity when the flow is low. More common for large-scale production of hydropower are the hydroelectric dams or water impoundment systems. And this is where you get storage of water in a reservoir behind a dam. So this is a much larger dam here, right, where you're storing a large reservoir of water. And then you manage that storage of water by opening and closing gates here. And therefore you can control the flow rate of the water that is then going to turn this turbine and power this generator and therefore produce electricity. This is a much more common method because you can generate electricity on demand. Do hydropower advantages and disadvantages. And in class, we can talk about some of these really large water impoundment systems and how much electricity they produce, and then some problems with these dams. Again, these are clean, no greenhouse gases. They're also really efficient. So you get a high energy return on energy investment. You have a high energy conversion. About 90% of the energy captured gets converted to electricity. Solar and wind are 15 and 59% efficient. These are reliable. Right, you can get large reserves behind the dams, and then you're able to control the flow and output of electricity to match energy demand. They're relatively cost effective. The total cost to build and operate a new plant over its lifetime divided by expected energy output is 8 cents per kilowatt hour, which actually makes it competitive with coal, which is 7 cents per kilowatt hour, and natural gas, which is 14 cents per kilowatt hour. Also, these can provide these reservoirs that give recreational and economical opportunities, and you can get downstream flood control. Some of the disadvantages for hydropower is that there's a pretty high environmental impact. And this environmental impact includes impacting the river flow, the river temperature, the chemistry, the silt load. The reservoir itself can flood areas, which involves relocation of people and animals, plants, whatever is living there. It can flood agricultural land. And then any recreation that relied on this free-flowing river would be limited. The reservoirs themselves can be problematic because these large reservoirs are going to hold more heat and contain less oxygen than free-flowing rivers. So you're essentially changing this system from this free-flowing river system that kind of winds and bends and it has all these different micro ecosystems within it to this large reservoir ecosystem that is much, much different. So you're not only putting in this artificial reservoir that didn't exist there before, that's this new ecosystem, but you're also altering the dynamics of any river ecosystems that are downstream. Another problem is fish that travel up and down the river, like salmon. They will be blocked from traveling, and we'll talk about some of the solutions for that in class. Another disadvantage is the construction of the dam itself. So cement produces a lot of CO2. Dead plants and organisms that are in the flooded areas produce a lot of methane. And then lastly, you can get sediment accumulating. Next up for our renewables is geothermal. Geothermal energy uses heat from the natural radioactive decay of elements deep within the earth, and then convection currents bring that hot magma, that heat, towards the surface where it comes close to groundwater. That groundwater gets heated, and then there's a couple different options for using that hot groundwater to create this geothermal energy. One option is to pump the hot groundwater directly to radiators to heat a home. Another option is to pump that hot water up to a generating station using the steam produced from the hot groundwater. And then you pump the cold water that has dropped off its heat in the generating station back into the earth to be reheated. You can also use a ground source heat pump or a heat exchanger where you can collect heat by circulating a liquid in pipes underground. That liquid gets heated and then returned to the surface. In Iceland, actually 87% of homes have this geothermal type of ground source heat pump. So you can use geothermal for temperature regulation, but you can also use it to generate electricity by using the hot groundwater to produce steam. Then that steam runs a steam turbine. The heat from the decaying radioactive elements deep within the earth is essentially non-depletable in the span of any kind of human time. That groundwater that carries heat to the Earth's surface, that could be depleted if it's not used sustainably. So in order to use that hot groundwater sustainably, you would need to return the water to the ground, as you can see right here, to be reheated. So that's one way to do geothermal sustainably. Areas with greater tectonic activity are going to be better for geothermal energy. So when we went to the Azores, they have a lot of tectonic activity and they had a big geothermal plant. The temperature at about 3 meters underground remains fairly consistent year-round. You can do geothermal anywhere, but there are areas where the crust varies in thickness. So you're going to have some places where you're going to have to drill farther down to get the temperature that you're interested in. All right, we're going to do geothermal advantages and disadvantages. One of the advantages, like other renewables for geothermal, is low emissions. This is also the most reliable source of renewable energy because it's constant. The pumps for geothermal are very efficient. They use 25 to 50% less electricity than conventional systems for heating and cooling. And once these are in place, they're pretty low maintenance. Also, no noise and no aesthetic problems because they're underground. Some of the disadvantages, one is that the extraction of geothermal can release some hydrogen sulfide, which can be an unpleasant smell. Some areas are going to be better than others, so you can have some areas that will actually cool over time and not provide as much energy. And then the big advantage for geothermal is it's a really high investment cost. There's a lot of testing and then installation costs involved. And then there's also land that's required. So this might not be as good of a idea in the city. Next up is biomass, which is our potentially renewable source of energy. And there's a higher percentage of use of biomass in developing countries. It makes up about 10% of the world energy consumption. Biomass is divided up into solid biomass, which includes wood, charcoal, and manure. You can also include other animal products and other plant remains and municipal solid waste in the solid biomass. Then there are biofuels. So these are things that have been refined into liquid fuels and include ethanol and biodiesel. All of these fuels contain a great deal of carbon, and then you burn those fuels, produce electricity, and then burning the fuels will release that carbon into the atmosphere. The difference between this and fossil fuels is that with fossil carbon, you're releasing that stored carbon that has been stored for millennia. With this biomass fuel, these are considered modern carbon. So you're returning the carbon to the atmosphere where it had been until recently. So if you allow the vegetation that has been burned to grow back, then the net change of atmospheric CO2 is zero, and then you're carbon neutral. Here's just a look at what biomass fuel consumption looks like globally. One kind of neat thing about biodiesel is you can use old cooking oil as your biodiesel fuel. So biodiesel fuel is one of those liquid biofuels. An option for a pretty sustainable version of biomass is to use algae. Algae grows really, really quickly, and you can extract an oil from it that can be used as a biofuel. So now we'll do our biomass advantages and disadvantages. One advantage is to use it as a waste disposal mechanism. So you can use garbage, manure, crops, and burn it for energy, and therefore there's really no waste. Could also be a secondary crop product, so it gives additional value to those crops. And biomass can be stored with very little energy loss. And then if you are in an agricultural system, you have a constant energy source. It's all modern carbon. So you're emitting little or no greenhouse gas in terms of fossil carbon, so you can be carbon neutral. The crops that are used in biomass can stabilize the soil, so crops can stabilize soil and therefore reduce erosion. And in some cases actually improve soil fertility. Then there is also with biodiesel, if you're using old cooking oil that would be thrown out, you can use it to power a vehicle instead. Some of the disadvantages, you could use wood from forests that could lead to deforestation if those forests aren't replanted or if the timber is harvested in a non-sustainable way. There's also the cost of harvesting and then transportation and handling that can all be expensive. Growing, storing, processing the biomass requires a large amount of space. And then some fuel sources are going to be seasonal. And then you could actually compete with food production. Our final renewable is hydrogen fuel cells. A fuel cell can convert chemical energy from a fuel into electricity through a chemical reaction of positively charged hydrogen ions with oxygen or other oxidizing agent. So this can produce electricity continuously as long as the inputs are supplied. So the hydrogen fuel cell is made up of a few components. You have an anode here, an electrolyte solution here, and a cathode. An anode is going to be a catalyst that oxidizes the fuel, which is here, hydrogen. And it's going to an anode strips the electrons off of that hydrogen. So the anode strips the electrons off, and you can see those electrons here. The electrons cannot pass through this electrolyte solution here. Only the positively charged hydrogen can. So since the electrons can't pass through this electrolyte solution, they have to travel in this direction through this wire, and the movement of electrons generates an electric current. This cathode on the other side is going to accept those electrons as they travel through that wire, and then it's going to take those electrons, join them up with the hydrogen again, and produce water. So hydrogen comes in, loses its electrons, those electrons are forced to travel through this wire, generating an electric current, and then they meet up with the hydrogen again, and then you've got this input of oxygen gas, so water is created, so water is your waste product. This is what a hydrogen fuel cell car would look like. So you can see you have to have that air input here, and then you have your hydrogen tank here supplying your hydrogen gas to the fuel cell, and then you have water being discharged. That generation of electricity from the fuel cell right here will then either go to the motor or to a battery. Here's just a little bit of a contrast between an electric car using solar power and then this hydrogen car. So we'll do hydrogen fuel cells. Advantages and disadvantages. It's renewable, so the energy is abundant in supply. The byproducts are clean because it's just water. Hydrogen gas is non-toxic. And it's much more efficient than other sources of energy. So you can get more miles than a vehicle with equal amount of gasoline, and it has a high amount of power that you could use for spaceships, 3 times more potent than gasoline and other fossil fuels. There's also both portable and stationary applications. So it's portable, or you could use it as stationary. Some disadvantages: hydrogen is very expensive to extract, so we need cheaper and more sustainable ways to harvest it because that limits extensive utilization. Storage is complicated for the hydrogen gas because it has to be compressed to liquid state and then stored at lower temperatures under really high pressure for effectiveness and efficiency. It's difficult to transport in large quantities because of those reasons, and it's highly flammable, which gasoline is also highly flammable. But potential dangers: leak detection is really difficult because there's no smell, you need sensors. And then lastly, you need other forms of energy that are not renewable, potentially not renewable, in order to separate the hydrogen from the oxygen. So there is some minimized fossil fuel use, so it's not totally eliminated. And that wraps up the different types of renewable and potentially renewable sources of energy and their advantages and disadvantages.